Hi dear students, so this is Dr. E. Vijaya Babu. So we are doing a continuation of network analysis lecture series of lectures, right? So in the previous classes, I think we have understood the concepts of voltage division, current division, okay, KCL, KVL methods, also star delta transformation methods to solve the problems of networks, right? So after that, what I have done is I have explained you one of the standard procedure. So if you have a ambiguity, which basic method to be used to solve the network problem, okay, so I said you to use a standard procedure, that was a nodal analysis procedure. I think we have solved all the cases of nodal analysis. Okay, so similarly, in the same way as a nodal analysis, you have the one more standard procedure to apply on any network. So that is what we call it as the mesh analysis. Okay, so in this lecture we'll try to go ahead with the mesh analysis. So coming to the procedure of this mesh analysis, okay, so if you try to really remember the nodal analysis concepts, okay, there each and every node you have given a nodal voltage and you have taken that as the variable, right? So that is the variable and you have expressed the KCL equations in terms of those variables and then you have solved them. So finally you might have got the nodal voltages. So once you got the nodal voltages, it is very easy. Okay, you can calculate any unknown parameter in the circuit. Okay, so that is the thing what we have done. So now here in the same way we are going to understand how to apply the nodal analysis procedure for a given network problem. Okay, so first of all, coming to the mesh analysis. Okay, so we'll try to understand what will happen in the mesh analysis. Usually mesh is a loop in which it does not contain any inner loops. Okay, so that is usually the definition of mesh. Okay, so to understand the mesh analysis procedure, so as there was a standard procedure for the nodal analysis, in the same way you have a standard procedure for mesh analysis. So whenever the circuit is given, first of all, you should there you have identified what? You have identified a number of nodes in nodal analysis. Now the thing what you have to do, you have to identify the number of meshes. You need to identify the number of meshes. So once you identify the number of meshes, then okay, you try to indicate the mesh currents now. There you have indicated the nodal voltages. Now here you need to indicate the mesh currents. So indicate the mesh currents, something like I1, I2 and so on IN if there are n meshes. Okay, so now the next thing, once you have indicated the mesh currents, then you try to, there you have applied KCL at the node, right? Here you need to apply KVL at the node. So apply KVL in the, so there you have applied KCL at the node. Here you need to apply KVL in the loop. Means all loops you need to apply KVL, right? So once you apply the KVL in the loop, next use Ohm's law once again to express the voltage in terms of mesh currents. Then once you got the mesh current equations, okay, upon solving equations, finally calculate mesh currents. So there finally you have calculated the nodal voltages. Here finally you have calculated the mesh currents. Okay, so once you get the mesh currents, it is very easy for us. So you can calculate any unknown parameter in the network. Okay, so as a nodal analysis, I already told you that it was a combination of applying KCL and the Ohm's law. Okay, the mesh analysis, I can say, so it is the application of KVL in the loop, and then after applying what? Ohm's law. KVL in the loop and applying Ohm's law. Okay, so this is a standard procedure compulsory you need to follow to apply mesh analysis on any network. Okay, now not only understanding this procedure is important, but you should know how to apply these points on any network given. Okay, that is most important. So that is why what I try to do before going ahead for the problems, so I will try to take one simple circuit. Okay, then I will try to make you understand how you can apply the mesh analysis. So try to consider a circuit something like this. So just for an example, I can take the voltage sources as V1 and V2, and the value of resistors I try to consider it as simply R1, R2 and R3. Okay, so as I said, the first step. So what is the first step here? So the first step is you need to identify the number of meshes. So here number of meshes in this is equal to 2. So directly you can say there are 2 loops here. Okay, now next the point is you need to indicate the mesh currents. So I will try to take mesh currents I1 like this, I2 like this. Okay, immediately you might be getting a doubt that so why I have to only the clockwise direction of I1 and I2. It's up to you. Okay, you can take both clockwise direction, both anti-clockwise direction, or else take I1 clockwise, I2 anti-clockwise, or else take I1 anti-clockwise and I2 clockwise. So anything you can fix, but once you fix the direction of I1 and I2, then throughout the problem you should not change the direction of I1 and I2. So this is the thing what you need to understand. Okay, so usually clockwise nature is very easy for us, so that is why I have took it as clockwise, but it is not restricted. You can take any direction as if you want in the directions of I1 and I2, right? So I took I1 and I2 as the uh, uh, mesh currents. Now going ahead, actually one more thing, important thing you need to understand in this logic is, now I will try to mark the current on the conductor. Okay, how much amount of current that is flowing in the conductor at any point in the network. So that I will try to plot it now. Understand clearly, depending upon what? Depending upon I1 and I2. Okay, so that means, understand clearly. So this is I1, right? That means I can consider it as what? I1 going like this. Similarly, I2 is going like this. Okay, for a better understanding, or else I can say this way, I1 after the voltage source, I1 before the resistor, I1 after the resistor, I1, and this way, I1, okay, this way, I1, this way, I1. This is how the I1 circulates in the first loop. Okay, next coming to the value of I2. Okay, so I'll try to show you with red color for better understanding. So I2 clockwise na, this is I2, this is I2. Next after the voltage source it is I2. Here once again it is I2. Then in the R3 branch the current going up is what now? I2. Okay, so I1 is flowing in the clockwise. Similarly, I2 is also flowing in the clockwise. Now you can clearly understand the current through the R1 resistor is how much? I1. The current through the R2 resistor is I2, and the current through R3. I will try to draw this separately. This is the understanding, best understanding what you want. Okay, if you try to keep the arrow something like this, then this current will be, the net current will be I1 minus I2, because I1 is going down and I2 is coming up. Or else, if I want to locate or direct the current upwards, if I show the arrow upwards, then the net current here is, so I2 is going upwards and I1 is coming down. So this is also very important logic. Okay, that means the amount of current flowing through R3 is not different. If at all, if you want the current going down, it is I1 minus I2. If at all the current going up, it is how much? It is I2 minus I1. Okay, that is also be important point that to be noted. Now, going ahead, once again I try to redraw the circuit now. Okay, so to apply the KVL, so this is R1, R2, then you have a voltage source here, and you have a voltage source here. So the value, this is V1, R1, R2, R3 and V2. And the loop current, this is I1, and the loop current, this is I2. Okay, now in this problem, so how to apply now? So I think I have identified the number of meshes. Going back to the procedure once again, identified the number of meshes. I indicated the branch currents I1, I2, I3. Now I need to write the KVL in the loop. Okay, so to write the KVL in the loops, I have a simple shortcut procedure to apply KVL in loop 1 and loop 2. The simple shortcut procedure is simply, this is something friend and enemy concept. So it is simply a friend and enemy concept. Okay, I think most of you watching here are a BTech students. So in the first year, some of your friends. Okay, in the second year they become your enemies. Okay, the enemies in the first year, they become your friends in the second year. So likewise, I will try to make you understand the friend and enemy concept in applying the KVL here. Okay, so in applying the KVL, every time I try to walk in the loop. Okay, so now I'll try to show you with the red color now. So I'll try to apply KVL in loop 1. If I try to apply KVL in loop 1, okay, so you start walking from here. Okay, so you reached this point, then immediately you are touching the negative terminal of V1. That is why you can consider minus V1. Okay, then you are here, you are going like this. Whenever you are walking, okay, the current coming with you is always your friend, and the current coming opposite to you is your enemy. So that means current with you is friend and current opposite to you is enemy. So friend means you need to take plus, enemy means you need to take minus. So this is a simple shortcut you can follow. Okay, so to apply KVL in the loop. Now see here, I have come to R1. So whenever I am walking in the first loop, compulsory I1 is my friend, because I1 is walking along with me, because I am walking clockwise direction. I1 is also along with me, right? So I am here. So I1 is my friend. When I am at R1, I1 is my friend. So that is why I am using this as plus, because I1 is my friend. So that is why R1, I1. Okay, then you are having, coming to R3. Whenever you are walking through R3, so I'll try to show you the red color. You are here now. You are walking in this direction, going down. Whenever you are going down, I said current with you is your friend. That means I1 is your friend. That means R3 into I1 is your friend means plus I1, and I2 is coming opposite to you, right? So in R3, okay, I1 is coming with you, I2 is coming opposite to you. So that means it is our enemy. So that is why it is minus I2. Then you are here. then you are here. However, there is no drop across the conductor, right? It is a equipotential body. You are here and you have reached the destination. That is why this is exactly equal to 0. So in the simple way, you can write the KVL. Immediately you can ask me, so is it required to walk only in the clockwise direction? It is not required. Even you can walk in the anti-clockwise direction. However you are walking, the current with you is your friend and the current opposite to you is your enemy. So this is a simple logic, okay, which can break the KVLs in the loops. Now, going ahead, applying KVL in loop 2. Okay, now I try to start here. I walk like this. I'm touching the negative terminal of V2. So that is a minus V2. Then I am here. Okay, here if you clearly observe, I am walking like this, but current I2 is opposite to me. So that is why applying Ohm's law, current is opposite to me. That is why it is minus. Okay, then you are here. You are at R3 now. Okay, so at R3, if you clearly observe, I1 is with you now, but I2 is opposite to you. So plus I1 minus I2. Okay, then you are here, coming back to the original point. That means you have completed the loop. So that is why this is equal to 0. Actually, nothing I have done the sum of voltage drops in a loop is equal to 0. So that is the definition of KVL. But the important thing is anybody will write KVL, but the notations are most important. Okay, so that will most of the time the notations will carry forward you to the wrong answer. So you should be very careful in giving the notations. That is why I have explained you this simple concept, that is whenever you are walking, current coming with you is your friend and current coming opposite you is your enemy. Okay, immediately you can ask me, in the second loop, I have walked in the anti-clockwise direction. Okay, even also you can walk in the clockwise direction also. That means you can, even though you can walk like this, no issues. Okay, so you will be getting the same answer. So I think you got 2 equations. Okay, so rearranging the 2 equations, that means equation 1, if you try to rearrange, so R1 plus R3 into I1 minus R3 I2 equal to V1. This is equation 1. And then writing the equation 2, rearranging the equation 2. So I1, R3 I1. Then if you take I2 quotients, so take minus common. So R2 plus R3 I2 equal to V2. This is equation 2. So however, R1, R2, R3 will be given in the problem. V1, V2 will be given in the problem. But the unknowns are I1 and I2. So solve to get the mesh currents I1 comma I2. Okay, so you can solve this mesh currents to calculate I1 and I2. So this is a simple procedure you can apply. Once you get this I1 and I2, so you can calculate anything you want in the circuit. As in the nodal analysis, finally we have calculated the nodal voltages. Okay, so after that we have calculated anything we want. Similarly, in the same way, once you get the mesh mesh currents, then immediately you can solve whatever the unknown is being asked in the question, so that easily you can solve it. Okay, so this is a standard mesh analysis procedure that should be followed to apply in any network to get the right solutions. Okay, so with this lecture I am concluding the mesh analysis. So in the next lecture, so we'll try to apply the same concept and by taking some problems. Okay, so we'll try to continue the problems of mesh analysis in the next lecture. So however, thank you for giving this opportunity. So if you really enjoyed the videos or like the videos, immediately like and comment it and subscribe to our channel. So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.